Example 3 says, the marketing department at Widgets Inc. found that when certain widgets are sold at price P, dollars, so each widget is sold at a price of P dollar per unit, the numbers X of widgets, so X represents the number of widgets, sold is given by the demand equation. X equals 1,500 minus 30p. Find a model that expresses the revenue as a function of price P. Remember at the beginning of the notes, we stated revenue is always going to be X, which is the unit sold times the price, okay? In this case, it says find the revenue as a function of P. That means P is the input. So since we have X and P here, students, we have to rewrite this equation. We have to write R of P, students, equals. We cannot have X in our equation, so we have to substitute X out. So P can stay, but in the problem itself, it says X equals 1,500 minus 30p. So X gets 1,500 minus 30p, okay, and then that represents X, that substitutes X, and then times P at the end. You can distribute this out, but you don't have to. So the final for our revenue model with respect to the price is RP equals P times the quantity, 1,500 minus 30p. You can write the P in the front or the back. That's really up to you. What is the domain of R? Okay, so let's talk about the domain. Because your input is P, students, and P represents the price, okay? Now, yes, we can sell an item for $0. So we know we can start, the smallest price we can sell is $0. We cannot sell something for $, okay? We're not gonna pay someone to take our widget. Now, what is the largest price we can charge? What does that mean? It means that, hey, we don't want to go in the negative, right? So we want the revenue, the lowest revenue is 0. So that allows us to take the revenue equation, student, and set it equal to 0. So we're going to have 1,500 minus 30p times p. We are going to take each factor and set it equal to 0. So p equals 0, that will give us one value of your domain. Then we have 1,500 minus 30 equals 0. Take each factor. Move the 30p to the right, so now we have 1,500 equals 30p. Divide both sides by 30. So p equals 1,500, y'all, divided by 30. As you can see, you can cancel this out. 15 divided by 3 is 5. There's a remaining. So we have 50. So there are two values of p, 50 and 0. So that is the price that we can set, which means that is the domain. So P has to be inclusive from 0 all the way to 50. You can even write it as an interval notation, bracket 0, 50, bracket close. What unit price should be used to maximum the revenue? So this is when we are going to use a calculator if you want, or guys, find the vertex, right? Now the vertex, since it is a quadratic, and it both at 0 and 50, it's on the x-axis, we can find the midpoint as well. So that's really up to you. So to find the midpoint, or aka the vertex, okay, of the quadratic, I'm gonna write vertex of quadratic. Vertex of the quadratic, x equals negative b divided by 2 times a. That's if it's in standard form. Since we have 0 and 50, midpoint of that is 25, guys, okay? So x equals negative b over 2a, which your input x is now really p. P equals negative b all over 2a, which we don't have to do any work because halfway between 0 and 25, guys, is going to be, I'm sorry, I just gave you the answer. Halfway between 0 and 50 is going to be $25, okay? So the unit price should be used to maximize the revenue is $25. But let's confirm that. Don't trust me on the basic math. Let's confirm that with our calculator that I got for free from online, since I can't really use one or use my TI. So let's do, okay. So clear out y equals, clear out this, and type in our equation of open parentheses 1500 minus 30p, which is 30x, close it, times x. And we already have the domain. Important to find the domain because in your window, I want you to type in the domain. Your x min is going to be 0. Your x max, students, is going to be 50. So, oops, back 50 and zoom fit, which is 0. Okay, so let's go and trace the very top, which is second trace maximum, which is number 4. And it's going to say left bound. Right there looks good. Right bound. Go all the way over. That looks great. Okay. So 24.999999, which is pretty close to 25. So our math is doing a good job. Let's go back to our notes. Okay. What unit price should be used to maximize the revenue? So based on our algebra or graphing calculator, we should get $25. If this price is charged, what is the maximum revenue? We don't really have to do any work, students, because we graphed out the revenue, and the order pair at the top, the vertex is 25, 18,750. So the 18,750 is going to be the revenue, max revenue that we can collect. Okay, $18,750.